Welcome back, guys, to another one of my mathematics tutorials. In this session, we will be looking at the parallelogram law of vector addition. It states, if two vectors acting simultaneously at a point can be represented both in magnitude and direction by the adjacent sides of a parallelogram drawn from a point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through that point. Now, in order to fully understand that, we can consider this diagram here. Let's look at our point O. We are seeing that from O, there are two vectors originating. I'm looking at OB, which is called our vector B. I'm looking now at OA. That's another vector called A. They both originate from that point O. Now, in order to perform addition, we have learned that one vector must flow into the other, meaning it must be connected by a head-to-tail format. For example, PQ and QR. So we can see the tail of PQ is here and the head of PQ is here. Then we can see that the tail of QR is here and the head of QR is here. So PQ and QR is connected in that head-to-tail format. Now we can perform addition. So when we add PQ and QR, we are going to get our resultant vector PR. So on the diagram, it is going to be this vector here, which is going to be the vector PR. Now let's go back to our diagram here. Notice that these two vectors, A and B, are not connected in such a way. They are both connected using their tails. So in order to perform addition for these two vectors, we must apply the parallelogram law for vector addition. And it states that when two vectors originate from a single point, in order to perform addition of those two vectors, it is going to be that diagonal passing through that point. Now, if we look at our vector A, based on our definition of equal vectors, we can see that we can draw a vector BC such that it is equal to the vector OA. And I'm going to write that here. OA is equal to the vector BC. We can see that because in our diagram here, it has formed a parallelogram, and in a parallelogram, you have two pairs of equal sides. So our vector A here can be formed, which is the vector BC, because BC and OA are equal vectors. Now, remember, we wanted to perform addition of B and A, and it was not connected in our usual format, head to tails. So now, if we look at our vector B and A here, it is connected in such a way that we can perform our addition. B plus A is going to give us this new line or our resultant vector here based on our previous knowledge of triangle law for vector addition. So when we look at OB and BC, when we add those, we are going to get this resultant vector OC. And let me write it on the side here. OB plus BC is going to give me our resultant vector OC. And you can see that in your diagram here. From O to B and then from B to C gives us O to C. And that is denoted as A plus B. Now let us look at how we can apply our parallelogram law for a particular question. So in this question, they are asking us to determine the vector SU. To get from S to U, I can take the path S to V and then V to U. Or I can take the path S to T and then T to U. Now, any path that you take, you are going to end up with the same resultant vector. So let's take the path S to T and then T to U. And remember, this is going to result in S to U. So we can see here that S to T is X. So we can write X here. But what is T to U? That is unknown. Now, T to U is the same as S to V. They are both equal. So I will put a note here. TU is equal to the vector SV. This is a parallelogram. So we can see that TU is equal to the vector SV. And SV is that vector Y. So I can call this part here Y. Now I can put TU is equal to our vector Y. So X plus Y is going to give us our resultant vector X plus Y. So now I can draw that pathway because I have just determined that SU is that vector X plus Y. And there you have applied your parallelogram law for vector addition. Don't forget to like, share, and subscribe for more of my videos.